Welcome back to the Deep Dive. Today, we're really getting into the weeds with some pretty specialized tech. It's all about large-scale video distribution. Yeah, we're looking at something called the WolfPack 4K 30Hz 16 by 32 AV over IP PoE Matrix Switch. It's a mouthful, I know, but forget the name for a second. Think scale. 16 inputs, like, satellite boxes, computers, whatever, going out to 32 different screens. This is the kind of gear you'd find powering, say, a huge sports bar, maybe a fancy retail setup, or even corporate control rooms. Price-wise, for this specific 16 by 32 setup, you're looking at around $14,325 today. But the really interesting part, it's built to grow. The documentation says you can expand this thing out to like 100 TVs, maybe even more, just by adding more network switches.
It really is a shift in how these big installs are done. So for you listening, our goal today is to cut through the jargon. We want to explain why this move to AV over IP audio video over your standard network cables is such a big deal, especially compared to, the older ways like HD base T or those massive clunky analog switches. We're really focusing on efficiency, how it scales, and some, frankly, surprising control features baked right in.
Okay, let's start with the basics then. A matrix switch. In this context, what are we really talking about? Conceptually, it seems simple. Any input can go to any screen, or one input could go to all 32 screens at once.
Exactly, total flexibility. But doing that reliably, especially with high-res video, used to mean really expensive proprietary boxes and lots of specialized, often bulky cables. The leap forward here is using standard, everyday network stuff. Your Cat6 cables, your Ethernet switches, it's much more cost-effective. And what's really clever is how they've streamlined the actual hardware. The boxes that send the signal to transmitters or TXs and the ones that receive it at the receivers, RXs, they're physically identical. Oh, wait, they're the same box.
The very same unit. You just tell it what job to do using PC software. Is it sending or is it receiving? Think about that. Less inventory to manage, less chance of grabbing the wrong part for the install. It just makes the whole deployment process much cleaner.
That is smart. Definitely simplifies things. But okay, you've got potentially 16 sources, maybe 4K video, going to 32 screens. That sounds like a ton of data flying around. How does this system handle all that without needing, say, a super expensive 10 gig network? Because that would blow the budget fast.
Right, and that's the core efficiency piece. It comes down to really smart bandwidth management. They're using H.265 compression, similar to what's used in modern streaming services, but it's tuned here for very low latency distribution within a building or campus. And here's the kicker. Even if you're pushing multiple 4K 30Hz sources, maybe doing complex stuff like quad view on some screens, the total bandwidth needed for the entire system, it stays capped at just 1 gigabit.
Hold on. 1 gigabit for everything. All 16 inputs, all 32 outputs, potentially running 4K. Just 1 gigabit total throughput needed on the network backbone. That's the magic. They've compressed it so well that standard, affordable 1G Ethernet switches can handle it all. That's where you see huge cost savings compared to older systems or systems needing 10 gig infrastructure. That jump to 10 gig gear, it's expensive.
Okay, so standard network gear, but with a catch, right? You mentioned the switches. The sources say this setup uses, what, a 48-port and a 24-port switch, plus Wi-Fi for control.
Yes, and the key detail there is they must be IGMP Ethernet switches. IGMP.
IGMP, what does that do?
So when you send video over network to lots of places, that's called multicast traffic. IGMP stands for Internet Group Management Protocol. It basically tells the switch which specific screen needs which specific video feed. So instead of just flooding the whole network with all 16 video streams all the time, IGMP directs traffic intelligently. It says, okay, TV number 7 only asks for source 4, so only send source 4 down that cable. It prevents the network from getting totally overwhelmed. Crucial for keeping that 1G limit effective.
Ah, got it. Smart traffic management. Okay, so that's the brain, the switches. What about getting the signal and, importantly, the power out to all those 32 displays? You mentioned PoE.
Yep, power over Ethernet is standard here, and that's a huge time saver for installers. It means the little TX and RX boxes don't need their own separate power bricks plugged in at the TV or in the rack. The power travels right down the same network cable as the video data.
Much cleaner wiring, especially considering the distances involved.
Exactly. And the distances were pretty impressive. If you're using good quality CDA6 or even better CT7 cable, you can push that 4K 30Hz signal up to 450 feet.
450 feet, wow.
Yeah. And even with standard CAT5E, which is, pretty common, you still get a solid 330 feet. And that's with or without using the PoE feature.
The documentation also mentions something about STP868B cable. Is that critical?
Well, the specific number isn't the main point. It's the STP part, shielded twisted pair. They recommend using shielded cable, especially for those longer runs or in environments with potential electrical interference. That shield just helps protect the signal integrity, cuts down on noise, and keeps that 4K picture looking sharp even way out at 450 feet. It's good practice for high-performance video.
Makes sense.
Yeah.
And for the user, say, in that control room, switching between camera feeds or sources needs to be fast, right?
Yeah.
You can't have long delays or black screens.
Absolutely not. And this system delivers what they call seamless switching. It's basically instantaneous, no black screen when you change sources. The overall latency, the time from the source sending to the display showing, is also really low, around 80 milliseconds, which is, practically real time for human perception.
So it feels immediate.
Pretty much. That makes it suitable for live monitoring, command centers, places where you need instant visual feedback.
Okay, this is where things get really interesting for me. Beyond just routing video efficiently, the control aspect, the documentation highlights this feature. Wireless iPad and Android tablet. Real-time video preview of every source device. Tell me more about that. Real-time preview, what does that actually mean here?
This is probably the standout feature for managing a system this large. It's not just static images or slow refreshing thumbnails on your tablet. The documentation is very clear. It's full motion video you're seeing live. So picture that sports bar again. Maybe they have 12 satellite boxes playing different games. The manager doesn't need to walk around or switch the main TVs just to see what's playing on each source. They pull out their iPad, open the app, and they see 12 little live video windows all playing simultaneously. It's a powerful monitoring tool right in their hand.
Okay, that is cool. Lets you verify content instantly.
Yeah.
But there have to be some limitations, right? What can't you do with that app?
Good question. Two key things to remember. First, the preview on the tablet. It's video only. No audio comes through on that preview feed. You see it, you don't hear it.
Right, okay. Video preview, no sound.
Second, and this is important, the app is for previewing what's on each source. And for routing those sources to different displays, it doesn't let you control the source device itself. So you can't use the WolfPack app to, say, change the channel on that DirecTV box or switch presentations on a connected laptop.
Ah, okay. So if I see on my iPad preview that source 5 is showing the wrong game, I still need to grab the actual DirecTV remote for that specific box and change the channel there.
Exactly. The WolfPack system routes the signal brilliantly, previews it for you, but it doesn't, reach through and control the source device's functions.
That makes sense. It's a distribution system, not a universal remote.
Precisely. Now, for setting the whole thing up, the main configuration happens on a PC, needs Windows, supports up to Win 11 according to the docs. There's a tool called XView, that's where you do the heavy lifting. Tell each box if it's a TX or RX, set up IP addresses, design your matrix layout, configure video walls.
Video walls, we'll get to that. Is there anything else software-wise?
There's another little utility, Design Editor, which lets you customize the XView interface, maybe add a company logo, that sort of thing.
And the mobile app for the tablet control.
That's called DB Stool, works on iPad and Android. But crucially, your tablet needs to connect to a dedicated Wi-Fi access point that's plugged directly into the same network as the matrix switches and the TXRX units.
Okay, so dedicated Wi-Fi for control. And one last check on control, can you access it through a web browser, like a web GUI?
No, the documentation specifically says no web GUI. It's all managed via the PC software XView or the mobile app DV Stool. That's a key point for system designers to know.
Got it. PC software or the app. Let's shift then, because you mentioned video walls. This thing isn't just a point-to-point router. It has processing built in, right? Which makes it way more versatile.
The video wall processing is actually handled within the receiver units. The RX is connected to the displays. This means it can natively support more complex layouts without needing extra boxes.
Like picture-in-picture, PIP, or showing 4 sources on one screen.
Exactly. PIP is supported, and also quad view, putting 4 sources onto a single TV. Very useful. And for building actual video walls, you can easily configure, say, a 2x2 wall using 4 TVs, or a bigger 3x3 wall with 9 TVs, all set up using that XView PC software.
And it even handles rotation for portrait displays.
Yep. Optional rotation settings are there 90, 180, 270 degrees, so quite flexible for different display orientations and creative layouts.
It's pretty amazing how much is packed into this one system, all running over that standard 1 gig network.
It really is. And we haven't even touched on everything. It also supports KVM over IP.
Keyboard, video, mouse.
Right. So you could have your Soul's computers locked away securely in a server room, but control them from a workstation connected to one of the RX units at a desk somewhere else. The keyboard and mouse signals travel back over the network.
Okay, that's handy for control rooms or secure environments.
And it apparently supports live streaming of the 4K 30Hz feed, too, so you could potentially stream the output from a source across your internal network, or maybe even out to the internet, depending on the setup. Adds another layer of utility.
Now, audio. You mentioned it briefly, but audio can often be tricky in these big systems. Let's clarify how it works here.
Yes, definitely need to be clear on this. Both the transmitter TX and the receiver RX units have audio outputs, little 3-pin connectors, usually for a 3.5mm jack. This lets you do two things. You can feed external audio into the TX along with the HDMI video, embedding it into the stream. And then on the RX side at the display, you can pull that audio back out using the 3.5mm connector. Useful for sending the audio to a separate amplifier or local speakers.
Okay, so you can extract the audio associated with the video that's currently playing on that specific display.
Exactly. It extracts the audio corresponding to the video feed being shown.
So let me make sure I understand the limitation here. If I have, say, input 1 playing video from a news channel and input 2 playing music, I cannot send the video from input 1 to TVA while simultaneously sending the audio from input 2 to that same TVA.
Correct. That's the crucial point. This system functions strictly as an audio de-embedder or extractor. It is not a separate audio matrix. The audio is locked to its video source. Whatever video input you select for a display, you get that input's associated audio. You can't route audio independently from the video using this system alone.
Right, so if you need independent audio routing music everywhere, but different video zones, you'd need a completely separate audio matrix system alongside this.
Precisely. That's a critical design consideration for anyone planning an install. Don't expect this box to solve complex audio-only routing needs.
Okay, that's a really important clarification. So, wrapping things up for the listener, what have we really seen here? It seems like we've got a system that tackles 3 big challenges pretty effectively. 1, distributing high-res video, 4K, 30 hertz in this case. 2, doing it really efficiently over a standard 1 gig network. And 3, offering this powerful real-time visual control with that tablet preview feature.
Yeah, I think that sums it up well. And if you think about the bigger picture, system design-wise, the scalability is key because it uses standard network switches. You can just keep adding more switches, daisy-chaining them or cascading them, as the documentation calls it, to add more and more ports, more inputs, more outputs. And the system architecture means it all still behaves as one enormous unified matrix switch, even as it grows. The expansion potential is, well, it's practically unlimited, just constrained by your network design.
It really feels like it simplifies things by moving away from proprietary hardware limitations. That idea of a unified system, video walls, KVM, even streaming potential, all on one network layer. Makes you wonder, doesn't it? What kind of new control centers or monitoring hubs could you design when all these capabilities are integrated like this? And think about the simplicity that the TX and RX are the same box, just defined by software. How much complexity does that remove from planning, installing, and even maintaining these massive systems? Maybe that simplicity is the real innovation here. Something to think about how that kind of streamlined, scalable approach could change how you tackle your next big video project. Thanks for joining us.